So, uh, welcome everyone for those that weren't there already. Welcome, Ryan. Um, my name is Matthew. I'm currently working for the Cardano Foundation, and I've been there in the Cardano community since ADA was $3, my first purchase. Yeah. Um, so we're going to talk about analytics for Cardano today. I want to show a few things, but first, who here has already been doing analytics for Cardano or not for Cardano? Yeah, that's a good question. It will happen later. All right. Who here has already? Who here? Oh, one sec. Who knows this tool? Yeah, Apache Superset. So it's a tool that was created like in the 12, 15, 16, something like that, out of Airbnb because they needed like better tools for business intelligence to take good decisions, right? So we're gonna get that at the end, but let's go back to the beginning. All right. So I'm gonna walk through this quite fast, I think. So here are the few points we're gonna go through. First, let's define analytics, right? So what we can say is that data analytics is basically the practice of examining data and at the end, do whatever you want to draw better decisions. So there are different kinds of analytics. Basically, we can like split into those four categories. Descriptive, like what happens, what did I notice, why did it happen, predictive, what will happen, like that's the hot topic today is with ML, machine learning, and prescriptive, like what should we do with that data, like what we have that data. So basically, every analytics workflow like follows this pattern. Like you collect data, you clean it, you transform, you analyze it, and then you visualize it at the end. Usually the hard part is getting the raw data to the right question. In blockchain, in Cardano especially, the collect step is where like the most difficulty happens. All right, so I think blockchain analytics is a really good topic because basically blockchains, I mean public ones are open ledgers, right? So contrary to traditional finance where everything is like hidden and siloed, everything is public in blockchain. So you can do a lot of data analytics on it, and even if you are not like in the room with the people having the data, because everything is public. And yeah, this basically makes it the most transparent financial system, but you all know about that. So what can we learn with data analytics? We can learn things like that interest different kind of personas in blockchains. There are obviously the things like protocol health that interest mostly the people that build the protocols, right? Build the blockchain, build Cardano. There are also like staking and delegations, governance for all the people that deal with governance. Of course, it's very important. And the usual suspects, DeFi and tokens, memes, whatever. So what's the current landscape of data analytics for Cardano? Basically, we have like these different levels of the stack. Like you have the consumption level, which is like what the final user will try to use directly. So you have tons of explorers. You have things like dApp tools for DeFi or Cardano. You have Seagorv for governance thing. We have maybe Dune, which is coming soon, which is one of the well-known institutions doing data analytics on different blockchains. Then when you go one step below, you have the API providers, the indexers. At the first Builder first, there was a specific track for indexers because they wanted to discuss with each other because there were so many indexers. Yeah. And then you have the Cardano node. For now, soon you will have others. But yeah, most of those paths for data analytics, they end in PostgreSQL somewhere. So usually in DBSync or Yassi or those things. So we have like a rich ecosystem. We have things of everything, but we are missing a lot of important stuff for people doing analytics on a daily basis. We are missing formats that are optimized for that. Generic database format like PostgreSQL is not optimized for data analytics. We are missing a lot of like people that share public data sets for things that have already transformed and that make them accessible for the community. And we are missing a lot of easy download and query access because, well, currently, if you want to do that, you have first to run a node, an indexer, and sync for days, or if you have Mithril, like it can go a little bit faster, right? But yeah, it's still a very hard task, and it's not the task of someone who is doing data analytics, it's the task of someone doing like infrastructure or something like that. So what we want to explore is using like data formats that are specified really for this task. So one of these formats is the Parquet file. I can like share a little bit of the difference, for example, the advantages we have for data analytics in Parquet file compared to Postgres. The main one is that these files are just files. They don't need a server, they don't need a process running, and they are columnar. So the data is stored in a way that if you are interested in only one kind of information, you have that information really fast because it's only that information that you can query linearly in the data sets. So you don't have to like go through all the different types of things that are in the transaction if you are only interested in the fees of the transactions, for example. Also, it takes less space because you can compress it easier than database. So that's nice because you can have this on a laptop instead of this. And it goes even further, like over 1 terabytes if you want to have all the tables in Yassi store, for example, for mainnet. This is for the whole equivalent of the 1 terabyte of Yassi store with all the raw data plus the aggregated data for the stake, for all the things. So you have everything there. To my surprise, but not to my surprise because like, I've been discussing with the Yassi store team, the block spinning team a little bit. They recently added something called an analytics store module to the Yassi store, which basically exports all their tables to Parquet files. So this means they have like 47 tables exported, everything, blocks, transaction, governance, and they are exported in a daily fashion in a high style. So I'll explain later what that means just after. It's compressed, and you can configure what you export if you control the Yassi store process. So on top of those Parquet file, which is just the host of the data, you can also add some kind of helper tooling, which is, for example, known as Duck Lake. Basically, it's like an overarching scheme of ways of doing queries. Like you can basically add a schema on top of all of your files so that it looks like a database. These are the options in Yassi store if you want to do that. So once you have exported those database into a Parquet file, anyone can query those Parquet file with an optimized database for Parquet file and for columnar file like DuckDB. You don't need a server, you don't need a node, you just have the file and you do something like that. For example, you have tons of Parquet file for transactions and you just do SQL query that looks like this and like it works almost instantly. I can do the demo now, but I will do it later because the slide is later. So I don't want to get sidetracked too much. And most importantly, it's a data format and a way of processing that is compatible with teams that are that do this on the daily basis, that work with Python, with Spark, with Jupyter, Apache Superset that you saw before, and basically any other kind of tooling that works with Parquet files. So I have been trying to use this approach on a few different things. One of the topics is governance analytics. What you can do is you can do something like a dual layer approach. Like you have your layer 0, which are the raw Parquet files. And you can, of course, like make your queries directly on that. But if you have a set of queries that you will do regularly, it's much better to have like an intermediate layer where you create your own transformation processes to generate a few focus data sets, maybe with some pre-aggregation, so that you can make then views that are really fast. Then on top of that layer, you can just have some SQL views that are just for convenience, right? So that you can display them easier in dashboards. These data sets are usually like partitioned into a lot of files, which also means that if you are interested in analyzing a subset of those data, you don't have to download the whole database. We can, for example, host those things on Cloudflare, and you can download just the few files you want. It can be restricted in a timeline, or it can be restricted in one of the tables. So you can pretty much get up to speed like very, very, very fast. These are like some metrics that the governance health working group defined for Intersex, things they want to follow to see how governance is going. I won't go through all that. These are just examples from the first category, but there are a lot of different categories for following governance health. And I wanted to present that initially, but I've had some bad cleaning on my data, so I won't show charts that are really ugly. So instead, I will show something else, which is what you saw here. These are generic superset generic charts about like Cardano chain health in general. You have things like the transaction amount per epoch. So I guess you can probably know what happens here. Like, who knows what happens here? Like, raise your hand if you have any idea of what happened at that time. Which one? Probably, but no. Yeah, I think it was the launch of SundaeSwap. Yeah. Fees per epoch, yeah, usually very correlated with the transaction volume. This is in ADA amount, so it can be a bit decorrelated, but yeah, generally it's still very similar. Kind of things like circulating supply, the treasury reserve, the things that made some drama over there. Yeah, you can follow unique stakers. When you see news like Cardano has 1.3 million delegators, it's not delegators, it's just unique stake key address. But yeah, I mean, that's still a good number. Staking rate, active pools. We are a little bit down because like everyone is struggling, but I hope it's going to get better. Distribution of rewards has been lower, and that's why it's really important that we do it right for the distribution of funds with Treasury, right? So that we don't misallocate funds too much. Other things like how stake is flowing and chain density. This one was interesting to add. So do you know what happened here? Raise your hand if you know what happened here. Yeah, quite a lot. It was a battle between pigs and chickens, right? We had. Sorry. I think he told who he was, right? Oh no, I don't know. I just know it was a decoding error. Oh, you are doing the decoding error. Okay. Right. Well, now you can laugh about it, but I'm sure it was pretty stressing at that moment. Okay. So this is the kind of tool that you can have and that you can make quite easily. And I can show another thing, for example, for showing the efficiency of the requests. I have a few of those that you might like. So here is what the data looks like. I'm just gonna redo that so that it fits. Yeah. This is what the data looks like with the Parkifies. It's like arranged in categories, and if you go into one of these categories, you will see things like, sorry, yeah, data, analytics, no, yeah, and then let's go into main. Let's go into, I don't know, address. Oh, that's the only one that's empty. Yeah, right. I picked the good one. Sorry. I don't know. Blocks. Yeah, and they are organized by date, for example, and in each date you will see a lot of Parkifiers, and then when you make the queries, you can restrict the queries automatically to the dates that are efficient for you. So I have made a little example script that I can show you. Yeah, it's a little demo of some transaction that will be very expensive to do on PostgreSQL-based database. Here I aggregate everything, every type of not everyone, but these types of data into some names that I can reuse for the request later. And then I'm making a few requests that should be quite expensive, like aggregating the fee history over like the whole history of transactions, looking for the block production pools. Yeah, a lot of compute that take advantage of the columnar data. And if I run that, you can see it's pretty fast, right? We have, yeah, the fee history, like sorted by epochs, average fee, total fees, thing like that. So yeah, so that's pretty much it. Let's get back to the slides. Yeah. So the vision is that Cardano has a rich set of data. Here, I focused on governance data initially, but yeah, what we want to do is we want to have public data sets that are available and easily downloadable for a lot of people, and so that anyone can build analytics on top of it and show it. Especially there will be a high, inference entities like Dune Analytics or other that talk directly to institutions. But with this kind of information and with this kind of data that anyone can run on a laptop, I'm pretty sure we'll see community data sets, community dashboards that can show up on different type of things. Right, so that's the vision. Every Cardano data set in Parkify, downloadable by anyone, query easy, and analytics as a public good. And that's it. Anyone question?
Do you have enough data inside the transactions and blocks to reconstruct the original seaward that was seen on chain, or is it already kind of dismantled into smaller pieces?
Yeah, it's this one is dismantled. I guess if you want to, you can store the raw seaboard or so.
Yeah. No, because we tried something similar, but yeah, for storing for point lookups, Parquet was not providing any extra efficiency. But for this use case, seems like really interesting. And does DAGTV resemble Iceberg in any way? Is the same type of solution?
Yeah, somehow Iceberg is more making sure you can have an environment which is like a database with ACID compliance. You don't have issues with concurrency rights and things like that. So it's kind of a big thing. And DuckDB and the Duck Lake idea is just a concept so that if you use them in a single process, you have the same guarantees as it looks like a database, but you cannot do concurrent writes and things like that because you only have a single process to like manage it. It's not as complete.
Right. And I mentioned that Parquet files, as you aggregate new ones, the history becomes immutable, so that you can just cache things as you move forward, right?
Exactly, yeah. If you already have the Parquet files for the past history and you just want to update what happens the last week, you just have to change a few files depending on how you are aggregating your data and how you are like putting everything together in a few files, and then you just compute the new files for the new history. Yeah. So it's easy to like get new data once you have already.
If I can also ask a question. So this kind of queries, okay, I will not tell if they are easier, but they are easy, right? Because in this kind of structure, we are very often into following, for instance, someone, and in that case, graph-based databases usually shine, right? Because of course you can express it in SQL, but it's not trivial, really. I mean, for instance, if you want to say, okay, give me the cohort that was the most active and tell me how they spent in the last 3 quarters and how it distributed what they spent later, things like that, right? So have you think about this kind of approach? So which could be realized because there are some graph databases that are that could work on Parquet. So that would be my first question. And the second one is whether you tried time series databases, for instance, like Druid or things like that. They are mainly all about timestamps, but these timestamps could be easily mapped into or converted into our epochs and things like that, right? But they are usually also very interesting, especially as we get traction and we are going to have more events and things like that. So maybe this is also a way. So these 2 questions, the graph databases for expressing of these graph-like queries, and another whether we try this time series database specialized for that.
Yeah.
Thanks.
So,
and one question. Very often these time series databases are GPU based. So you've got very huge boost because of that. Okay, thanks. Sorry for...
Yeah. Regarding time series, I cannot answer you because I have not tried those type of workflow. Regarding your first question about graph databases, it's clear that when you are analyzing a network like Cardano transactions, it's naturally from graphs, right? Even a direct acyclic graph because you can only spend things once and don't go back in time. So there are a lot of tools for doing that. And my hope is that if you provide people a format that they are familiar with, like Parquet files for data analysts, they can do themselves the transformation to the thing that is optimized for their workflow. But I haven't, like, I spent a little bit of time trying to analyze the Snake ecosystem and the Snake graphs. You can find a few things interesting there, right? If you do that, like especially you can find like a few addresses that have a lot of back and forth with enterprise addresses, which are probably market makers, something like that. So it's interesting to look into, but I haven't had a lot of time to do that. And also I want to say that this is something that has been in a back burner for me. Like I do a few different things and I try to come back to it like regularly, but like what I presented is most of the work relies on what Satya's team did for DBSync, right? So most of the work that will be useful for this type of workflow and that will be useful for data analytics platforms like Dune that was signed with the Pantad recently. This is work by those teams. Like I'm presenting this because I think it's cool, but that's like, yeah, mostly not my work.